Welcome to the dojo, ninjas. Man, I remember seeing an integral like this, and I'm told that you're supposed to memorize that the answer looks like this expression where you have the absolute value sign, and you forget to put the absolute value sign on the test and you miss points. It's frustrating, right? You've been there, I'm sure. But by the end of this video, I want you to understand why you need this absolute value sign. And before I unlock the understanding, my name is David, and in the past in college, I tutored students like yourself at the engineering calculus level, and I'm a software engineer who's made fun apps like the game you can check out below. But to answer the question that you came to this video for, can this expression ever be true? Well, the answer is sometimes. Maybe you know when this is actually a true statement, and you can tell me in the comments below, but hang on, because for the rest of you, let's dive right in. You see how I have a 1 over x right here? I want to start by graphing 1 over x because sometimes drawing something visually can help us uncover understanding things better. Now for the hyperbolic function 1 over x, as we all know, it looks like this graph where you have a hole at the origin. So if I were to ask you what the domain is, well, that's pretty simple, right? It's all real values of x, except that x cannot be 0 because dividing by 0 is not allowed. Now, even though the answer for the integral has a natural log of the absolute value of x, let's assume we don't know that yet, and we want to just look at the domain of the natural log of x function, the parent function we're trying to get to, right, after integration. Now, that graph is different as expected, and its domain is simple to see visually, but it is different. We know in this case that the domain of the natural log function is all real values of x, where x has to be greater than 0, right? So the reason why it's important to also look at the domain of this parent function is you need to remember that when you integrate, your parent function still has a domain restriction of its own. And if it helps even more, I've put together this table for you where we can see side by side the domains we got for each. Now, hang on. I know I'm writing the domain a little bit different here than I did above. Here I'm using set notation, which you may have learned in pre-calculus. So in case you need a refresher, these open parens here mean it's an open interval, which means the value is not contained. You can never contain infinity or negative infinity, and 0 for both cases is undefined, right? And then this U is the union, which means we're grouping together two domains. So what's happening here is if we look at 1 over x, you can see that on the left here, we're talking about all the negative values that are allowed. And on the right, we're talking about all the positive values that are allowed. And we're bringing them together with this union. However, for the natural log of x function, you can see that it's all real values that are greater than 0 for x. But also, even though 1 over x has this part, that part is not allowed in the parent function. And that's why we need the absolute value sign.